Okay, this should be our final video in this series, and it's not going to be as detailed as the other ones. But this is where we got to. We can pull this line with our load cell, so we've got graphics working, and I sort of along the way planned to have hardware abstraction, and that's because you know there's other good devices out there like this one. So to me, this one, and there's a 2350 version now as well. This microcontroller is about the pinnacle in terms of these RP2040 style devices. On the right here, that's its Wi-Fi antenna. So it has built-in Wi-Fi. It has a boot button and a reset button. I like having a reset button, and that's mainly because um, the feathers from um, the feathers from Adafruit also have reset buttons. And it has a USB-C socket on it, and I really don't have time for anything that doesn't have a USB-C socket anymore. Especially the poor design of the Raspberry Pi Pico, where eventually, if you unplug and plug this in, you'll break this off. Eventually, it happens. Whereas these guys, so that's the Adafruit feather, and this is the Challenger from ILabs, right? And this one doesn't have a LiPo socket on it. This one does. You can get with and without LiPo sockets. Uh, you trade 4 GPIO pins to get LiPo. And so this Adafruit one has LiPo as well, which means we can, maybe there will be another video at the end of this to show you how to get it running on in battery mode. And another reason I like the feather form factor is because there are a lot of feathers, which is what Adafruit calls their little hats that go on top. So this one is a OLED screen with some buttons on it. So it's got built-in buttons. And because the feather goes straight into the board, like that, there's no configuration for things like the buttons or the pins to hook it up. So that's the wiring done compared to the wiring of that one. So much, much easier to work with when you can just plug them in together like that, right? And I've already wired it up on the left here, so I can just, so we can just take this board out there, take out our amp, and it's already wired up to take the amp like that. And just check that my powers are in the right place. So there we go, we've wired it up onto a different board. And we can put the other board out of the way. And just plug that in. There we go. We powered up, and let's see if we can get that to sit nicely on a stand. Not really, huh? With that cable coming out the bottom, more or less. And then if I pull this, there we go. We've got our 2 bars, and we release the one, and it goes down. So that's the same program running on a second device. Let's go see how we would do that. Obviously, I've written this already, but I'm now going to work through the exercise of getting there. So let's go have a look. Let's put that in the middle there. So what do we need to do to get this working? So we have already added a second hardware file, right? I created this new file a while ago, the Challenger hardware file. And if we've done our hardware abstraction correctly, then the only code we're going to have to add is in this hardware file. So there it is. Doesn't do anything right now. It doesn't even have a screen. Now, Ada calls their Adafruit calls the add-on that you put on there in their feather format. It's called a FeatherWing. So if you look in the devices folder, you'll see a FeatherWing with this thing's name, and this thing is the 128 by 64 OLED FeatherWing. So I've already written a device driver for it. If you've got a device that I don't have a driver for, just let me know and I'll happily write it. I've got an enormous hardware collection, and I'm very happy to add more just to add. And then let's go look at our other one. We had in here, I think these settings are going to be the same. Let's have a look. So no, maybe not. Let's take these text width and text lefts from the other one. And because it's a narrower screen, we're just going to start the text on the left-hand margin like that. There we go. So we've set up our text. What do we need to do in initialize? Well, we can overclock this device as well. And unlike the Raspberry Pi Pico, so with the Pi Pico, I could overclock to 270 like that. With the Adafruit board, not Adafruit, with the Challenger board, I couldn't get it to go above 250 reliably, so that'll have to do. We got the same thing where we want it to be in portrait mode, like that. Now, where we do in the previous one, we had to do some initialization of the button, because we made our own debounced button, so we had to pin mode it, and we had to attach it, and that sort of thing. Because in this case, in the Adafruit case, the pin mode's going to be the pin's already predefined on those pins are already on the device. It's got 3 pins on the device. We're not going to need to do as much work. So if we go down there, we still need to initialize the device driver, so we can put a more robust error message in like that. And we're still passing it the button delegate. But it's got more than one button. So now what it'll do right now is it'll do the button activity. All the buttons are going to go to the same button delegate. So no matter which button I press, it's going to reset. But it does, if we look at the board, the buttons are labeled A, B, and C. So I can actually get that information from the pin of the button. If we go and look in the FeatherWing, it maps the buttons, depending on which it is, to GPIO pins. So you can map it back again with this pin to button, and you can get an A, B, or C out of it. So if you really wanted to, inside the reset here, you could say if the pin is the A pin, then do the reset. But I'm not going to bother. I'm just going to make it so that it works on all 3 pins, so I don't have to do anything. Okay, and the last thing I have to do is choose some GPIO pins for my create, to create my load cell. So that would be these 2 here, like the 2. Those 2 and that instruction there. Let's copy these just to create the cell. So let's go and do that. So we go in here and we create our cell from the GPIO pins. And we're going to want to define those pins. I should put them up top here. The configuration stuff can be at the top of the file. Now, those are the same pins as the other board, which are probably incorrect. So let's go see what pins we really need. So I've got the pinout handy of the Challenger board. And what do we put them in here? We put them in the first 2 pins above the ground. So it'll be pin IO16 and IO17 over here. So let's go have a look at that. So here, first 2 pins above the ground were IO16 and 17, right? So let's go see what we want to do there and which way around do we have. And again, my clock and data, I'm always use yellow for the clock. So I know the lower one is the clock. So that means 16 is going to be the clock and 17 is going to be the data. And I'm just going to take a swing at it and hope that's going to work. I think I'm done, right? So that's how much code I had to do to make it work on another device, to switch between 2 different devices. Here's hoping. There we go. Device ready. Guess we can try and stand it up again. Doesn't like standing up with that cable. Very wobbly. Okay, let's load it into the debugger. And then Control F5. We're running it, we've set our tar, and we're pulling. So this is the latest project made to run on a second device. So that's the payback for the early effort we made in trying to make to do device abstraction with our two different devices. And I think it clearly shows that the benefits of working with one of these feathers that just directly plugs into the device. And just to be clear, this is not something unique to Adafruit and their feather form factor or this Challenger board. So this is a Challenger microcontroller with an Adafruit FeatherWing. You can do the same with your PiPico W as well, because let's just pull this out. So with the PiPico W like that, there are also devices that work the same way as displays. So this display here, 128 by 128, has 4 buttons on it. These two have joysticks and 2 buttons. So, and these are OLED displays, so they'll be low-res monochrome, but much faster than there's less data to transfer for a monochrome screen. So there we go. There's one working that way. So plugged into the PiPico. So it's not specific to Adafruit. I just happen to like their form factor. Yeah. All right. Hardware abstraction solved. Thank you for watching. Enjoy the project. Give me comments if there's more things I can add or more things I can explain. Oh, I might add one more chapter on battery power at some point. Cheers.